Today we'll be discussing the concept of formal charge and the significance of formal charge from the Structures and Properties unit. Before we begin, let's recall a few ideas we considered in grade 11, using the example of carbon tetrachloride. We drew Lewis structures so that the central atom was the most unique and there would be similar bonds around the central atom. This is actually the most stable Lewis structure, where in fact there are actually multiple ways to draw a Lewis structure for the same compound. Today we'll be going through the following example. The question gives us the following three configurations of CnS- and asks which of the three provides the most stable arrangement of chlorine, nitrogen, and sulfur. To solve this problem, we will have to find the formal charge of each atom within each configuration. To do so, we must understand the basic concept of formal charge, which is that even after bonding, the number of electrons around each atom is equal to the number of valence electrons in the neutral form. To calculate the formal charge of an atom, take the number of valence electrons it has and subtract the number of bonds it has in the compound, and then subtract the number of lone pair electrons it has. Before we start working out the problem, it is worth noting a few common errors students often make while solving these types of questions. Firstly, make sure that you know how to draw correct Lewis structures. You may need to refer to your grade 11 notes if you struggle with doing so. Also, really understand what each element in the formula means. The formula calls for the number of lone pair electrons, not the number of pairs. Similarly, the formula calls for the number of bond pairs, not the number of electrons being bonded. Now we can get started. These are the corresponding Lewis structures of the three configurations of CSN-. Again, the accuracy of these diagrams is essential in solving formal charge questions. Let's start with CSN-. We'll begin by looking at the carbon atom. Carbon has 4 valence electrons, 2 bonds, and 4 lone pair electrons. Thus, the resultant formal charge of carbon is -2. Sulfur has 6 valence electrons, 4 bonds, and 0 lone pair electrons, giving it a formal charge of 2. And finally, nitrogen has 5 valence electrons, 2 bonds, and 4 lone pair electrons, giving it a formal charge of -1. Now let's repeat this process for CSN-. When we apply the formula for formal charge on each atom, the resultant formal charge of sulfur is 0, the formal charge of the carbon atom is 0, and nitrogen has a formal charge of -1. And finally, let's repeat the process one last time for CnS-. Here, carbon has a formal charge of -2, while nitrogen has a formal charge of 1, and sulfur has a formal charge of 0. These are the results of our findings. The formal charges are listed to the right of each compound respective to each atom. SCN- is the most stable compound because each atom still has the same valence electrons it had before being bonded, whereas in the other isomers, some atoms lost their valence electrons to the other atoms. Generally, the configuration with the most formal charges that are equal to 0 identify the most stable form. This compound is also known as sulfur cyanide, a familiar compound to us. Still confused about the concept of formal charge? Maybe chemistry, the snowman, can help. As you can see, chemistry has 3 parts to it: a head, a body, and a base. If we look at a few arrangements of chemistry's 3 parts, we will find that some result in a more stable structure. The first arrangement of chemistry the snowman is clearly silly, as chemistry is clearly unstable and will likely fall over due to this immense instability. This makes chemistry very sad. The next arrangement is more stable, but chemistry still isn't as stable as he could be. Plus, he isn't too happy with having his butt in his face all day. The last arrangement of chemistry the snowman is clearly the most stable and thus makes chemistry the happiest. Think about formal charge as a way to find the arrangement of chemistry the snowman that makes him the happiest, or as finding the most stable form of any given compound. In conclusion, to find the formal charge of an atom in a compound, draw the Lewis structure and use the formula formal charge equals the number of valence electrons on that element minus the number of bonds it has minus the number of lone pair electrons it has. If all or almost all of the formal charges in the specific arrangement of a compound are equal to 0, then the proposed Lewis structure is the most stable form. Remember to draw your Lewis structures accurately and count your values correctly. The concept of formal charge is relevant to the unit of structures and properties because it can determine the most stable structure of a compound. It gives the reason why stable molecules are structured the way that they are. We hope you learned something from our lesson today. Thanks for watching!